Okay, the next animation I'm going to show you is currently called on my file Spacetime Perpendicular 12, which is not easy to find because I would have looked for the words cone or ellipses if I was searching for this file. But anyway, an interesting feature of the cone is that if you cut it along any most axis, you get a ellipse. And there's something interesting about these ellipses is that this point here is at the center of that ellipse. So if I draw a straight line through the ellipse in any direction, this is the center point of all of those different line segments. That one, or that one, or one of these. So it also happens that if I imagine, or this being a space-time diagram with t equals 0, say t equals 10, t equals negative 10 down here, and somebody is moving along at this, if a vertical line would represent stationary, and a line right along the cone going from here to, say, there would be the speed of light, and then anywhere in between those two slopes is going to be some velocity, some achievable velocity. Now what that means is if there was a flash of light here at time 0, you would have light going out in a sphere around from that point of origin, and it also means that this guy that is traveling in time from there to there, basically if he's got a different velocity than you, he sees instead of seeing this point in time and this point in time as being simultaneous, he sees this point in time and this point in time as being simultaneous. So that way he basically observes the same speed of light, but he does not observe the same events being simultaneous with each other. Now this animation went through several different iterations before it was complete. Here's the original Spacetime Perpendicular.gif, and I guess you can see from this one where it gets its names. All I'm graphing are the perpendicular lines in space. The two blue lines are perpendicular in space, and the two red lines are perpendicular in space, but then the black line is perpendicular to those lines in time. Essentially, this is what, if you are moving along that black vector, you would see the red lines being perpendicular and the blue lines perpendicular in space, as long as that really highly slanted line represents close to the speed of light. And then it looks like from there I was just trying to get the color right. So with this one, you see those black lines. The black lines with the black velocity line, it doesn't show up very well. So what was I trying to do? The third version has a different angle on it, so you can see it more what it would look like from the side. And this one turned out a little bit busy, but I tried to connect the ends of the red lines and the ends of the blue lines. This one is the same view from the side. And here's one where I first said, well, the velocity vector should be a different color than the cone vectors, but the green just does not show up very well inside the black. Again, there's the exact same diagram from the side, or animation. I guess I decided I didn't like those points coming down from the side, but I would like another layer at the top and bottom here. And once again, the same view from the side. And here I tried to reduce the number of lines around the edges. Now this one is getting closer to my final version, with the lines on the cone being very faint compared to the lines in the middle. Okay, and notice that this goes way off the grid each time it goes up. The next file, it just stops right at the edge, so it doesn't go to where you lose part of the ellipse, but you can extend that as far as you want. And then the last one. No, I guess I must have stopped with 12. So let's look at some of the objects inside this thing. There was a circle A, which had cosine A, sine A. And this was the central circle, the t=0 circle. Then there's the circle top, which was at t=1, and the circle bottom, which was at t=-1. And then apparently it was radius 1, because it's 1 cosine A, sine A. So A was an angle that incremented from 0 to 2 pi or something like that. Then we have the parametric equation for line 0, which has both looks like t=0, x=a, and y=0. This would have been the horizontal line, the line on the x-axis, and this one would have been the line on the x-axis at t=1. This is the line at the x-axis at t=-1. Here is the line. Okay, this is the time axis, so it moves along the time. And what's that? X=1. And I'm trying to figure out how I use that time 1. It looks like I applied a rotation in the xy plane at angle and angle plus pi to time 1. So I'll have to come back to that one, but at least I know time 1 and time 0 are just lines in the diagram, basically straight lines. And then we have this rotate xy and rotate tx. The rotate xy does a regular rotation. A rotation, since this is t, this corresponds to the x coordinate, and this corresponds to the y coordinate. So this is basically your standard rotation by an angle of t radians. On the other hand, this rotate tx is a boost in the t and x coordinate of rapidity equals t. I don't think there's a standard unit for rapidity. Something like hyperbolic radians, I guess, is what it would essentially be. And here I am defining another function, or yeah, it's a function because it returns an object. So when you input a rapidity, an angle, and a color, it will take line 0 and rotate it to the appropriate angle and accelerate it to the appropriate rapidity. It'll do the same thing with line top. It'll do the same thing with line bottom. And it does the line zeros with a gray thin line, or wait, line 0, it does, looks like it may be taking a parameter color thickness. Line top with gray thin line, and line bottom with a gray thin line, and line 0 with an explicit color that this thing takes in. Okay, so that is why on top you've just got a thin gray line here and thin gray lines here, and then you've got specific colors on that central one, and then thin gray lines down here. So that's what that part of the code is for. So what does the timeRender function do? It once again returns a parametric plot, and this time it's going to be based on the time1 object, and it's going to also rotate that in the XY plane and rotate it in the TX plane. And then it takes time1 again, but this time1 is rotated by angle. This time1 is rotated by angle plus pi. So that provides, I would say, at least 2 colored lines. And I see here that this has been commented out of the final version of the code. So probably what this was those vertical lines, which showed up in an earlier version of the code that connected like that point to that point and that point to that point all the way around, which I decided just didn't look very good. So the timeRender was basically not used. Now how about the cone? Cone sends out a parametric plot, and it is probably just one object. Let's see. Yes, this is the parametric equation for a cone. It allows r to go from -1, which would represent the bottom of the cone, to +1, which is the top of the cone. And then your x coordinates are controlled by r cosine theta and r sine theta. So the this first coordinate is the time. So the time is equal to the radius of the cone, and that's basically the description of the cone. And then this is just some trigonometry. Notice that the mesh style is gray. I think the default way a cone would look is like that, so I needed to kind of get rid of some of the lines that it would defaultly build. And actually looks like I actually planned on exactly which lines to stick in there, with a 0.25, 0.5, 0.75, 1, and then down to the negative numbers of the same values. With what R went from -d2 to d2. What's d2? d2 was given at the beginning as 3, so the actual cone, and this, I'm not sure if it shows up in the animation or not, the cone itself is rotated, even though that has no particular effect on the outer shape of the cone. It does have an effect on the mesh. So the cone itself extends all the way out to radius 3, but the actual mesh of the cone only extends out to 2. No, actually I didn't do it that way. I set up a second cone that has no mesh and that is kind of somewhat transparent. And this one I didn't bother to perform a rapidity rotation, a Lorentz boost on. So that creates the rest of the cone, the gray part of the cone. Now that we've got all of our pieces defined, we go into the full render program, which takes as variables rapidity, start, and increment. So, and then I created a module which has internal variables list and G1 and G2. So these are defined only within this part of the code. And so some of this seems a little mysterious right now. Why did I define G1 and G2 as internal variables, and G3, G4, and G5 were left out of that list? Well, from here let's go down and do a top-down view of the code, which is manipulate, show, full render, and the full render takes rapidity from pi over 4 to pi over 2. Now, my mistake. It takes rapidity from -2 to 2, starting with 0. Well, this video is getting kind of long, and there's a lot of stuff in here that is related to just getting the angle correct. Here's the corner view, here's the head-on view, and so considerable amount of that was devoted to trying to figure out like the viewing angle. And I think sometime after working through this, I figured out how the viewing angle worked a little bit better, so that I could plug it in for the animation to get it to the way I wanted. But at the time, I just kind of like played with these controls until I found what I wanted to get the angle right. In any case, the video's getting kind of long again, and I'm gonna have to leave this for now. Goodbye.